हेलो दोस्तों। चलिए दोस्तों, आज हम स्ट्रेंथ मटेरियल सब्जेक्ट्स स्टार्ट करते हैं। सिविल इंजीनियरिंग में ज़्यादातर स्ट्रेंथ ऑफ मटेरियल का क्वेश्चंस आते हैं हर एग्ज़ाम पे। ये मोस्ट इम्पॉर्टेंट सब्जेक्ट्स हैं। आज हम स्ट्रेंथ ऑफ मटेरियल में सिंपल स्ट्रेसेस एंड स्ट्रेन पढ़ेंगे। Concept of stress and strain. In simple terms, we can define stress as the force of resistance per unit area offered by a body against deformation. Stress is the ratio of force over area S equal to R by A, where S is the stress, R is the internal resistance force, and A is the cross-sectional area. Then strain. What is strain? Strain is the ratio of change in length to the original length. When a given body is subjected to some external force, strain equal to change in length by the original length. Saint Bernard principle states that we can use a more practical loading technique that is statically equivalent to the theoretical loading and obtain similar result at distances greater than the largest cross-sectional dimension from the load. ये स्ट्रेस और स्ट्रेन का कर्व है। U इक्वल टू अल्टीमेट स्ट्रेंथ एंड इसमें एक्चुअल रैप्चर स्ट्रेंथ होता है, और R इक्वल टू रैप्चर स्ट्रेंथ, Y इक्वल टू यील्ड स्ट्रेंथ एंड E इज इक्वल टू इलास्टिक लिमिट, E इज इक्वल टू पर्सनल लिमिट। एक्स एक्सिस में स्ट्रेन और एंड वाई एक्सिस स्ट्रेन डायग्राम ऑफ ए मीडियम कार्बन structure in steel. Okay. Suppose that a metal specimen be placed in tension compression testing machine. As the axial load is gradually increased in increment, the total elongation over the gauge length is measured at each increment of the load, and this is continued until failure of the specimen takes place. Knowing the original cross-sectional area and length of the specimen, the normal stress delta and the strain psi can be obtained. The graph of these quantities with the stress delta along the y-axis and strain E along the x-axis is called the stress-strain diagram. The stress-strain diagram differs in form for various materials. The diagram shown below is that for a medium carbon structural steel. Okay. Metallic engineering material are classified as either ductile or brittle material. A ductile material is one having relatively large tensile strain up to the point of fracture, like structural steel and aluminium, whereas brittle material has a relatively small strain up to the point of rupture, like cast iron and concrete. An arbitrary strain of 0.05 mm per millimeter is frequently taken as the dividing line between these two classes. Now, what is Hooke's law? Proportional limit. From the origin O to the point called proportional limit, the stress strain curve is a straight line. This linear relation between elongation and the axial force causing was first noticed by Sir Robert Hooke in 1678 is called the Hooke law, that within the proportional limit the stress is directly proportional to strain, or delta summation equal to E, or delta equal to K into E. The constant of the proportionality K is called the modulus of elasticity E, or the Young modulus, and is equal to the slope of the stress strain diagram from O to P. Then delta is equal to E into E. Now we read elastic limit. What is elastic limit? The elastic limit is the limit beyond which the material will no longer go back to its original shape when the load is removed, or it is the maximum stress that may be developed such that there is no permanent or residual deformation when the load is entirely removed.